So here is question number 11, everyone. In the conservative field, if positive work is done on a system by the field, then assume no other force is present. Pick out the correct option. Field is conservative and work done is positive. So it is clearly, we know very well that in case of conservative field or conservative forces, the kind of energy exists, or the conversion of energy is only from kinetic to potential, potential to kinetic. Alright, now let us read the options. Kinetic energy of system decreases. Alright, potential energy of system increases. Okay, potential energy of the system decreases. Fourth option, both 1 and 2. First of all, since we know very well that if work is done by conservative force, then it is very much clear that change in potential energy will be what? Negative of work done. Change in potential energy will be what? Negative of work done, means change in potential energy will be negative or it will decrease. Therefore, potential energy of the system will decrease or decreases. So from here we can say that option number 3 is absolutely correct. So we will go with option number 3 only. Now move on to the next, that is 12 number. So here is question number 12, everyone. Two particles of masses m1 and m2 are initially at rest at infinite distance. The relative velocity of approach due to the gravitational force of attraction when their separation is r will be what? Now first of all, let us consider the cases. Initially they were infinite distance apart, m1, m2, r is infinity, and they were at rest actually. So momentum in this case will be what? 0. Now finally, due to the force of gravitational attraction, they will come near, and at any situation when separation is r, the velocity, suppose m1 has v1, m2 has v2. The momentum p2 in this case can be written as m1 v1 minus m2 v2, as on this two block system there is no external force acting, so momentum will be conserved, and we can write p1 must be equal to p2, law of conservation of momentum. Therefore 0 equals m1 v1 minus m2 v2. From here we can write the expression for v2, that is m1 upon m2 multiplied by v1. Suppose equation number 1. Now let us apply the law of conservation of mechanical energy. Initially the system was infinite distance apart. The blocks were the infinite distance apart. Potential energy will be 0. They were at rest. The kinetic energy will also be 0. So the total mechanical energy initially will be 0. Finally, both are moving. So kinetic energy present, half m1 v1 square plus half m2 v2 square. And since two mass systems separated by a distance r, there exists a gravitational potential energy can be given as minus g m1 m2 divided by r, where r is the separation between them. Now rearranging and solving, we will get m1 v1 square plus m2 v2 square equals 2g m1 m2 divided by r. Now this is equation number 2. Suppose from 1 and 2 we have the value m1 plus m2 times v1 square equals 2g m2 square divided by r, or v1 we can write m2 times under root of 2g by m1 plus m2 times r. Now similarly we can calculate V2 from equation 1. We will get V2 as m1 under root 2g upon m1 plus m2 times r. We have to calculate the relative velocity at this moment. Now relative velocity can be written as V relative as V1 minus of minus V2, means V1 plus V2, and therefore V relative we can write directly now V1 plus V2, that is under root 2g m1 plus m2 divided by r. So this is the final expression for relative speed at the moment when the separation is small r. So after looking at the options, we can say that option number 1 is perfectly matching. So therefore we will go with option number 1 only. Now move on to the next, that is 13 number. So here is question number 13, everyone. A geostationary satellite revolving around Earth at a distance r from the center. If angular velocity of the Earth about its axis is tripled, then distance of satellite from the center of Earth such that it remains geostationary will be what? So first of all, we know time period is given by 2 pi by omega, the relation between time period and angular velocity. If omega is tripled, time period will be 1/3. So initially, according to third law of Kepler, that is law of periods, we have t square proportional to r cube, equation number 1. Now when angular velocity will change, time period will also be changed, and the new time period is suppose t dash. So t dash square proportional to r dash cube. Now t dash is what? 1/3. If you thrice the angular speed, t will be 1/3. So we can write t by 3 square proportional to r dash cube, and therefore suppose this is equation number 2, taking the ratio of 1 and 2, we get t square upon t square by 9 equal to r cube upon r dash cube. T square cancel out, rearranging, 9 equals r cube upon r dash cube. Now therefore the value of r dash is now can be written, r dash cube is r cube upon 9, or r dash is r upon 9 to the power 1 by 3. So this is our final answer, and that's why we can say that option number 1 is truly correct. So we will go with option number 1 only. Now move on to the next, that is 14 number. Here is question number 14, everyone. A hollow cylinder of mass m and radius capital R is rotating about its own axis with constant angular speed. If speed of particle at circumference is v, then the rotational kinetic energy of cylinder will be what? Rotational kinetic energy of any rotating object we can write half I omega square. Cylinder and hollow has the moment of inertia mr square, so half mr square. Omega is what? V by r. So therefore we can write omega as v by r. So omega square v by r whole square. Solving it gets us the kinetic energy of rotation will be half mv square. So moving at the options, we can say that option number 1 is absolutely correct. So we'll go with option number 1 only. Now move on to the next, that is 15 number. Here is question number 15, everyone. A solid sphere rolls down a rough inclined plane without slipping. Select the correct statement. So the condition or situation is of rolling. Question belongs to system of particle rotation. Now this is the block rolling down. Forces acting, its weight mg downward. Components mg sin theta this way, mg cos theta this way, and both are acting at the center. Normal reaction this way. Friction will act somewhere here, and this friction is responsible for rolling. So according to translational equation, the net force equals mass into acceleration. Net force down the plane given by mg sin theta minus friction, Fs we can write, equals ma. Suppose this is our equation number 1. Now for rotation, the rotational equation can be written: who is providing the necessary torque to rotate? Friction is providing the necessary torque to rotate. So force into distance, that is R, will be I alpha, I moment of inertia, alpha angular acceleration. One more step, Fs equals I we can write moment of inertia for solid sphere, that is 2 by 5 mr square into alpha, and alpha can be written as a by r, and one more r from this side becomes a by r square. R square cancel. We got the value of ma, that is 5 Fs divided by 2. Equation number 2. Putting the value of ma from equation number 2 to equation number 1, let's see what we are going to get. Mg sin theta minus Fs equals 5 Fs divided by 2. Therefore we have got the value of friction force, that is Fs equals 2 by 7 mg sin theta. Now let us go for the option. Option number 1. If theta is increased, friction force will remain constant. No, from expression it is clear that the friction is depend upon theta. Friction is depending on theta goes wrong. Second option. Some energy is lost in the form of heat due to friction between sphere and the plane. So first of all, I just want to tell you, if there is no slipping or if there is pure rolling, no work is done by the friction. In case of pure rolling, friction force does zero work done. So therefore there is no loss of energy. Second also went wrong. Third, friction will support the rotation motion of the sphere. Definitely friction is the force responsible for the rotation, responsible for the torque. Friction will provide the necessary torque. So that's why we'll go with option number 3, which is absolutely correct. Now move on to the next, that is 16 number.